To start, you have to identify your goal, the known, the implied, and the unknown. Secondly, you have to draw your free body diagram that shows Fn and Fg that are the same length and cancel each other out, with force of friction working opposite of force applied, which is 15 degrees northeast. You have to now find the normal force, and you have to apply Newton's second law to the vertical forces. Analyze the free body diagram to find all of the vertical forces that act on the crate. To find acceleration, apply Newton's second law to the horizontal forces. Then analyze your free body diagram to find all the horizontal forces that act on the crate. To find the time interval, use the kinematic equation that relates acceleration, initial velocity, final velocity, and time. At the end, you will be pulling the crate at 1.4 meters per second at 2.2 seconds after the crate begins to move. Some common mistakes and strategies would include knowing that Fn and Fg would cancel out. The motion is in the horizontal direction, and Fn causes the crate to accelerate. Direction of the motion will be positive in horizontal distance. There will be no motion in the vertical distance, and that means that there is no acceleration in the y-axis, which makes it equal to 0, which also makes F net equal to 0 in our calculations. The coefficient of friction always applies after the crate starts moving, and we have to validate our solution at the end. So for example, we need to know that newtons over kilograms would be kilograms times mass over seconds squared over kilograms, which also would reduce to meters per second squared for acceleration. We also need to know that 1.4 meters per second as our answer is not that fast, so it would make sense for our time to be around 2.2 seconds. Here is the mark allocation: 2 marks for the free body diagram for the x-axis and y-axis, 1 mark for step 1 to find Fn, and 1 mark to find acceleration after, and finally 1 mark to find t for your final solution at the end.